Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We'll go ahead and finish up the last half of section 1.2 here today. Talk a little more about domain, range, and some other qualities of functions in their graphs. So, first example here, we have a graph, and we're going to use that for several different questions. So first off, use the graph to determine the domain. Again, domain is, or the x value, so starts at -2 as you go to the right, stops at 1. Main thing you do have to watch is with that open dot means we do not include that value, so parenthesis around the 1. As far as the range goes, I think this is the first time we've really talked about range, meaning the y values. And the one thing you do have to be careful about here is just, even though there's an open dot, that may not always matter. Well, the minimum y value for this graph or function is 1, and the maximum is 5. And like I said, the fact that there's an open dot here really doesn't matter. Y can't equal 2 here, but it can over there. So it's just 1 to 5. With a unbroken interval there. So as far as any x-intercepts, meaning where does it cross the x-axis, well, for this one there are none. For y-intercepts, where it crosses the y-axis, now the only thing that we do want you to get used to for this, don't just tell us the y-intercept is 1. 1 is a value. An intercept is actually an ordered pair or a point. The point where it crosses the y-axis is 0, 1. And then the last thing here, f of -1, meaning find the value of the function at -1. Well, there's nowhere to plug this in, so what you actually have to do, remember this is our x value, so when x is -1, what's y? So just on the graph, go to x is -1, find where the y value is. Looks like it's basically at 2. So there is the first example. Now, little different example here with graph 2. Basically, you have a square root function that has been reflected. What's the domain? Well, here, your x values, as we go to the left, go to -infinity. The vertex stops when x is 4. As far as our range goes, the minimum y value is at the vertex of 0, and the graph as you go to the left does keep going up slowly to positive infinity. As far as are there any x-intercepts, again, we do want this written as an ordered pair. It crosses the x-axis, or I guess I shouldn't say crosses, but it is along the x-axis at 4, 0. Y-intercept, where it does cross through the y-axis, is 0, 2. And much like we did up here with one of the find a value of the function, what is the value of the function when x is 3? Well, go to 3 along the x-axis, find where the graph actually meets that value. Y is 1. So a couple of equations and graphs there. Or I guess I should say graphs. All right, one final topic. The zeros or roots of a function. Those are the values of x where f of x or y equals 0. So find the zeros of each function. So basically what we're doing is just going to replace f of x or y with 0. Well, for this one, it is a quadratic, so as far as our options go, well, the one thing I would not do, I would not complete the square. A is not 1, B is an odd value, so that certainly won't be an easy option. You can always look at, will it factor, multiplies to 10, adds to 1. Unfortunately, it does not work to factor. So our only option now is quadratic formula. So x equals opposite of b plus or minus square root b squared is 1 minus 4ac all over 2a, which is 2 times 2. So, -1 plus or minus, we'll just put a 4 on the bottom. And then when we work this out underneath the radical, we get 1 minus 40, so -square root of 39. Now, what this means, finding the zeros or where it, crosses the x-axis, well, because this is imaginary, for right now we are going to say there are no real zeros. When we work into chapter 2, we'll go back over the concept of imaginary numbers, but for now we're just going to say there are no real solutions or roots or zeros. Those three terms all essentially are interchangeable. As far as this next one goes, g of x equals square root of 15 minus x squared again. Set it equal to 0. To get rid of your radical, you can square both sides. So 0 equals 15 minus x squared. Here I actually like to move the x squared over and then take the square root. Main thing you do have to remember is when you take a square root, you do end up with both positive and negative square root of 15. For 15, there's nothing we can do to simplify it. The only way you can split it other than 1 and 15 is 5 and 3. Since those are not perfect squares, those are your 2 zeros or roots for that function. All right, for the last one here, h of t. So again, 0 equals 5t minus 3 over t plus 7. There's a couple of different ways you can look at this. When you have a function that's a fraction equal to 0, basically what that means is the numerator has to equal 0. If you wanted, you could even put 0 over 1, cross multiply, just kind of another way to show you how that actually works. If we cross multiply, 0 times t plus 7 remains 0. 1 times the 5t minus 3 equals 5t minus 3. So, like I was saying, when you have a fraction equal to 0, we're just looking for what would make the numerator equal to 0. So, to solve for t, add the 3 and divide by 5. For this one, I'm again going to just leave that as a fraction. There is just one root or 0 for that rational function. So that ends the final part of section 1-2. It's definitely, like most of the sections you'll see, a lot shorter than the first part. But other than that, that is 1-2.